Eastman.
Today, we will talk about the unboxing of the ES51.2-100LP. The accessories included are user manual, RJ45 cable, 1 meter red and black cable, screw fastener lugs, and mounting bracket. As you can see, the battery and accessories are completely wrapped with shrink wrap. On-off switch, reset switch, addressing switch, RS485 CAN interface, RS232 port, RS485 communication, RS485 for parallel port, power LED indicator, run LED, alarm LED, and this is the SOC, state of charge indicator, positive terminal and negative terminal. To turn on the battery, press the on-off switch. This is the main display of our battery, and by entering the main display, you can see its running parameters and features. On the far left, there is pack info. When you click pack info, you can see the complete voltage of the pack. Pack voltage now. Pack current 0, no inverter connected. Battery charge 49%. Remaining capacity 49 ampere hours, full capacity 100 ampere hours. This shows internal battery temperature. 4 NTCs installed. Each NTC shows temperature its area. This is our back button. From here, we can go back. Here you will be able to see the status. This is the running status where we can see which protections are activated inside our battery. If any protection is active in our battery, the text that is written in black will appear to us in red color. These are the protections in our battery: overvoltage protection, undervoltage protection, short circuit protection, overcurrent protection, and overtemperature protection. Now let's come to the warnings. If you see any kind of warning on the battery display, it will appear here in red color. For example, overcurrent, overvoltage, undervoltage, overtemperature, undertemperature. Now we will go back to our main menu. Here, the protocols of our battery are given. For example, you will see here that it is compatible with our S485 pylon, CAN pylon, and compatible with which inverters. This information is also provided here. Now let's move to the system. In the system, you will be able to see what the serial number of the battery is, what the software version is, and which language is set. Now, by going to the battery symbol, we can check the status of the battery. Here, our current status shows 0 ampere because it is not in the charging stage right now. Along with that, you will also see the battery voltage as 52.3 to 1 volts, which is its current state of charge. Along with this, you will also see the SOC of the battery here, which is still 49%. First, we will connect the battery and inverter to the positive and negative terminals using the provided red and black cables. Make sure the connections are always properly tightened. Now, we will turn on the battery using the on-off switch. First, we will ensure that the power LED indicator starts glowing and then becomes stable. The run LED indicator will flash. Along with this, you will also see the state of charge indicator, which shows the battery percentage. This is our LAN cable, and the definition of the pins given inside it is clearly mentioned in the manuals of both the inverter and the battery. As we are connecting the battery with the DAI inverter here, I am using CAN communication in the DAI, so the cable will have to be punched according to the given CAN pin definition. Accordingly, we have to connect the pins to the CAN. And after punching the same wire into the correct pin definition of the RJ45 or S485 connector at the slot given on the inverter, we have to connect it. This will establish BMS communication. If the pin definition is not correct, you will see a BMS communication failed error on the inverter display. After punching the cable on the correct pin definition, the cable has been inserted into the CAN port. The dressing switch is used to connect the batteries in parallel. If we want to connect one battery in parallel, we have to turn on the first switch. If we want to connect two batteries in parallel, we have to turn on the second switch. If we want to connect three batteries in parallel, we have to turn on both the first and the second switch. If we want to connect four batteries in parallel, we have to turn on the third switch. If we want to connect 5 batteries in parallel, we have to turn on both the third and the first switch. The first switch is numbered 1, the second is 2, the third is 4, and the fourth is 8. This way, we can connect from 1 up to a maximum of 15 batteries in parallel. For example, if we want to connect 7 batteries in parallel, we turn on the first 3 switches. Why do this? The third switch is numbered 4, the second is 2, and the first is 1. Adding these 3 gives 7. The 8 pins of the RS485 connector given on the inverter side should be properly punched according to the pin definition provided in the manual, and then connect it to the slot given for BMS CAN RS485. Once communication is established between the inverter and the battery, you will see LiBMS displayed here. Here, you will be able to see the associated battery percentage, battery voltage, current, power, and temperature. Along with that, you will also be able to see the protocol. Right now, there is no mains connected to our inverter. Once we connect the mains and run the load, you will be able to see the battery current here. At the moment, it is showing -1 ampere because only the battery and inverter are connected here and no load is connected. Now, when we connect a load to it, the display will show the discharging current. If you want to view or record its data on a laptop, then simply connect the RS232 to the battery and the other side to the USB port or connector. This is a PBMS tool with the help of which we can monitor the battery's running parameters in real time in a very efficient manner.
Eastman.